Hello, everyone. When we think about the search for life in space, we usually picture distant exoplanets orbiting other stars. But what if the most incredible laboratory for the origin of life isn't trillions of miles away, but right here, in our own solar system? What's more, what if it's actively working right now? Today we're talking about Enceladus. It's a small, icy moon of Saturn, only 500 kilometers or about 310 miles in diameter. From a distance, it looks like a quiet, frozen snowball. But that is, perhaps, the most deceptive first impression in all of space, because Enceladus is alive, geologically alive. Beneath its icy crust, dozens of kilometers thick, hides a warm, global ocean of liquid salt water. We know this for certain thanks to the Cassini mission. This legendary NASA spacecraft studied Saturn's system for years and noticed something astonishing. From the south pole of Enceladus through cracks in the ice known as tiger stripes, giant geysers are continuously erupting into space. They spray particles of water ice, vapor, and something else. Cassini did something no spacecraft before it was designed to do. It literally tasted this ocean. It flew through these icy plumes, and its instruments analyzed their chemical composition. And what it found there made scientists all over the world stop and stare. First, we learned that this ocean has hydrothermal vents, the very same kind found on the floor of our own oceans, black smokers. These are places where hot water, saturated with minerals from the moon's rocky core, bursts into the ocean. On Earth, it's precisely these vents that are teeming with life, life that doesn't need sunlight and feeds exclusively on chemical energy. Then we found methane, then hydrogen and carbon dioxide. This is the perfect food for microbes called methanogens, one of the most ancient forms of life on Earth. Then, just recently, in 2023, analyzing Cassini's data, scientists found phosphorus in the form of phosphates. This was a breakthrough, as phosphorus is absolutely essential for all known biology. It forms the backbone of DNA, RNA, and the energy molecule ATP. Even back then, Enceladus became the #1 candidate in the search for life. It had all of the big three: liquid water, an energy source, chemical reactions, and the key chemical ingredients: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. It seemed like it couldn't get any better, right? But it turns out it could get better. A new, deeper analysis of Cassini's data, published in the journal Nature Astronomy, has detected the molecule everyone was waiting for. A molecule that is the true holy grail for the chemistry of life's origins: hydrogen cyanide, or HCN. To most people, that name sounds like a poison. But for prebiotic chemistry, the chemistry before life, hydrogen cyanide isn't a poison. It's a cornerstone. It is one of the most important and versatile molecules needed to create amino acids. And amino acids are the building blocks of proteins, and proteins are what do all the active work in living organisms. The study's authors call hydrogen cyanide a Swiss Army knife among precursor molecules. It can participate in countless reactions that lead to complex organics. This isn't just one more ingredient in Enceladus's chemical soup. It's proof that this soup is actively brewing. This means Enceladus's ocean isn't just a passive environment suitable for life. It is a dynamic, powerful chemical factory that is creating, right now, the very same compounds we believe led to the origin of life on Earth billions of years ago. And that's not all. Along with hydrogen cyanide, researchers found evidence that Enceladus's ocean has far, far more available chemical energy than anyone had previously imagined. Previously, we thought the main fuel there was the reaction that forms methane. Scientists compared this to the energy from a small watch battery. But the new data, showing a diversity of oxidized organic compounds, points to a completely different scale. One of the lead researchers, Kevin Hand from NASA's Jet Propulsion Laboratory, used a brilliant analogy. If we used to think of a watch battery, the new results suggest the ocean of Enceladus might offer something more like a car battery. This is a giant amount of energy, capable of powering not just individual microbes, but entire complex metabolic processes. So, let's summarize. We have a tiny moon of Saturn. Beneath its ice, there is a warm, salty, global ocean. On the floor of this ocean are active hydrothermal vents. This ocean is saturated with all 6 elements necessary for life. It has an energy source as powerful as a car battery. And now we know it is actively producing hydrogen cyanide, the key building block for amino acids, the foundation of all life. Enceladus is not just a place where we might find life. Enceladus is a place that is showing us how life can emerge from non-living chemistry. The question, is there life there, is transforming into an even more intriguing one. If all the ingredients, all the energy, and even the assembly instructions are there, then what's to stop life from starting? Future missions to this amazing world, which are already being planned, might just give us the answer to one of the most profound questions humanity has ever asked. But what do you think about this? Could something be hiding in this dark subsurface ocean? Or is it just an incredibly complex but ultimately non-living chemical laboratory? Share your thoughts in the comments, and thanks for watching.